Again, welcome to College Algebra course. In this lectures, we're going to learn about how to, again, graph a functions and also how to determine the domain and also the range of a function from its graph. So our main objective is to go through how to graph a function by plotting points. Normally, we have two steps in plotting a function. A function is given, and we have to select the value of the input variable, which will be the x. Then if we know the value of the input variable, the x, which is our horizontal axis, we are going to find the y value from the function, and that will be our vertical axis. Again, college algebra, our model is based on 2 dimensions, so we need only 2 coordinates, x and y, to find a point. So every point in the graph is only x and y, 2 dimension. So again, 2 steps to graph a function. Come up with the value of x, find the y's, and you have a table with x and y values, then you plot the points. Also, we can use a vertical line to test if we have a function. An expression is given and we want to know if it's a function. We use a vertical line to test. Normally, when we draw a graph of the function, we are going to draw a line, a vertical line across the graph of the function. If the vertical line touches the graph only once, then it's a function. If it touches more than one time, then it's not a function. We're also going to learn how to determine function values graphically, and also how to find the domain and the range of a function from this graph. So normally the domain will be the x values, and the range will be the y values, which will be the boundary of this. For example, I may have a domain of an x value from 1 to 10. The range will be from -100 to 200. So again, range is the y's and domain is the x values. Also, we are going to recognize the most common functions in algebra. For example, in algebra, a linear function is a straight line function. Normally, in the expression, the variable have only one exponent. So the degree of the variable is only 1. Now, we normally have a parabola function. A parabola function means the highest degree of the variable will be 2. So the highest exponent will be square, the variable 2. Then we also have a cubic function. We have a log function. We have exponential functions. So basically, we will go through the most common functions in college algebra. Just by looking at the expression of the function, we know the shape of the graph of that very function. So here we start with the graph a function by plotting the points. So again, college algebra, we are dealing with only 2 dimensions. So our plane will be xy. X will be the horizontal axis, y will be the vertical axis. So here we say the graph of a function f in the xy plane, again, 2 dimension, xy plane, is the set of all points xy, where x will be the domain of the function, the horizontal axis, and y is the range of the function, which is the vertical axis, y equal to f at x. So let's start with an example. So here they told us to graph the following function. We have f at x equal to -2 times absolute value of x plus 3. So here we said the first thing we need to do is to come up with possible x value. Now, since this is an absolute expression function, it can be the reflection of the positive and the negative. So it's like a symmetric. When we have the x's values to positive, we also have it to the negative side, because we know absolute value. For example, absolute value of 2 is 2. Absolute value of -2 is also 2. So that's why absolute function always have the negative and positive side. So let's go through the first problem. So the function again is f at s equal to -2 absolute x plus 3. So we can see how the shape look. The reason why, as we said, we can come here and check. We decided to start with a point. Again, you can start with any value because this is a linear. So a student may start from -5 to +5, or -5 to +4, or -3 to +3. It's up to you. Here we plot a table. So as we said earlier, to plot a graph of a function is 2 steps. Get the table together. How do we get the table? This is 2 dimension. Come up with any value of x. Then you look for f at x. F at x will be the y-axis, the vertical axis, as you can see. So you have to come up. Here we decided to start from -2 to +2 with interval of 1. So if s is -2, what is the value of f at x or y? So we plot -2 here. Remember, this is an absolute. So -2 will give me +2. 2 times -2 will give me -4 plus 3. That's why we have -1. Then when it's -1 times absolute value of -1. First of all, the absolute value of -1 will be +1. So 1 times -2 will give me -2. -2 plus 3 will give me +1. So when s is -1, f at x or y is 1. Then when it's 0, absolute value of 0 is 0. 0 times -2 is 0. Plus 3 is 3. So when x is 0, f at x or y is 3. And when s is 1, is the same as -1 because the absolute value of -1 is +1. The absolute value of +1 is still +1. So 1 times -2 will give me -2 plus 3 will give me +1. So we can see that when s is -1, f at s is +1. When s is +1, it's still +1. The same thing applies to +2 is the same as -2 because the absolute value of -2 is 2, +2 is also 2. So we get -4 plus 3 is -1. So now we have 5 points now. Let's plot it. So we start with the -2 first. We have -2 and 1. So when s is -2, we have -1. So that will be our first point here to the left. -2 and -1. So y is -1, x is -2. Then the second, we have -1. So this is our -1. So and when s is -1, y is +1. So we have to go up +1. This is our center of origin 0. So this is +1. So we have our second point. Now, when s is 0, y is +3. So that's our third point at the top. Then when it's 1, we have 1. So whether -1, +1, we can see the same reflection. -2, +2, the same, because absolute value of -2 is +2. +2 is +2. So we can see the shape. So that will be our graph. And the second question, the same thing, 2 steps. Let's take any value of x. Here we decided to use x from 2 to 18. Now, this is up to you. You can decide to take any points you want. The reason why we are taking 2, 6, 11, 18 is you look at the 2 here. We have s minus 2. I don't want to get a decimal answer. For example, if I take 5, 5 minus 2 will be 3. Then I have to look for square root of 3, which will give me a decimal value. So we decided, okay, first of all, 2 is good. So when s is 2, what is the value of y? Is 0. 2 minus 2 is 0. Square root of 0 is 0. 6 is good. Why 6 is good? Because 6 minus 2 is 4. Square root of 4 is 2. 11 is good. Why? Because 11 minus 2 is 9. Square root of 9 is 3. So here we pick any value up. Remember that a square root function is not linear. It's not linear. This is the form we can see. It's almost like a log function. So because of that, you don't have to just take only 2 points or have the same interval. Here we're trying to get a solid value for y or f at x. So maybe next time I can pick, I know square root of 25 is 5. So I'm going to pick 27. When s is 27, y will be 5 because 27 minus 2 is 25. Square root of 25 is 5. So it's up to you how you pick your points. So if I have these 4 points, I'll come to the graph. When s is 2, y is 0, so I have my first point on the x-axis. And when s is 6, y is 2, second point. When s is 11, y is 3. So this is not a linear because we can see that the interval between the s and y values, they are not the same. From 0 to 2 to 3 to 4. But here from 2 to 6 is 4. From 6 to 5 is 6 to 11 is 5. 11 to 18 is 7 interval. So we have a curve function. So again, plotting a graph is 2 steps. You have the function, come up with any s value, find the f at s or y, and it's 2 dimension. Every point have x and y, and plot it. Now, next is how to use the vertical line to test if a function or an expression is a function. So use the vertical line test to identify functions. So here we say that if every vertical line that can be drawn and intersect the graph in no more than 1 point, then the graph represents a function. So first, in this question, a function will be given. Then I'm going to plot the graph of the function. Then I will draw a vertical line across the function. If the intersection of the vertical line, the graph is only 1, then we have a function. Now, if it's more than 1, then we don't have a function. So we have example here. A circle is not a function because when I draw a vertical line, the intersection will be at least 2. The second B is a function. When I draw a vertical line, the intersection is only 1. And C is not a function. It's kind of a parabola, but it's turned horizontal. It's open to the left. A parabola will open either towards up or towards down, not left or right. So since it's open to left, if we draw our vertical line, it touches twice. So it's not a function. So A and C are not a function because the vertical line touches twice, intersects the graph twice. B is a function because the vertical line intersects the graph only once. So yes, as we said, the graph fails the vertical line test because we have 2 points. The vertical line intersects twice, so it's not a function. And the second is a function. Now, when you are testing, sometimes we may have some parts it can only intersect once, and some parts may intersect more than once. So it's good to try the vertical line in more than one position just by looking at the graph. Here is a function because anywhere I have a vertical line, the intersection will be 1 time from starting to the ending to be only 1. C is not a function. We have 2 points. The intersection is twice anywhere we reach. So next we go to how to determine function values graphically. So we know that in many applications that involve function, we may not be given the equation of the function, but will instead have only data. So it's very important that we learn how to read the value of the function from the graph of that function. Now, if a question is given and the function expression is given, it's easy to find the values of x and y because the function is given. But what if a graph is given? How can we determine the answer? So the goal is to know how to read a graph. So for example, I have this graph here, but I don't have the function of the graph. I don't have the expression, the mathematical or algebraic expression of the function. I don't have it. So what I'll do, if they say we should find f at -3, then this means x-axis, -3 is x-axis. So I'll go to -3, that's the point right there, and I'll look for the value of y. In this case, I have this function. So I can see that at -3, the function f at x, -3, is equal to 0 because it's on the x-axis. And at 1, this is 1. So at 1, the function will be 1. That's 1. So again, let's go through the first. We said that when x equal to -3, the point is on the x-axis, so y is 0. So f at -3 is 0. Now, when s is -3, again, as we said, 0. Now, the second one, when s is 1, y will be -4. And that's the b. Let's go to b. Find f at 1. So at 1, y is -4. Again, the dimension here, I was saying 1 before because I thought every box is 1. No, the dimension we can see 8 to 16. So the difference is 4. When you cross each box on y-axis is 4. So 0, 4, 8, 12, 16. So this will be -4 from the graph. And then when we have x at 3, f at x, and we have 17. So again, reading the graph to again find y value. So here we also said when s is 3, so let's go back. When s is 3, we are in the middle of 16 to 20, so it will be 18. Now the C said find the value of x for which f at x is 17. So you have to go to the 17, draw a line and see where the intersection will be on the graph. So if it's 17, we draw a line, then we can see the intersection. We look at the x down. So that section is given. So now the next is determine the domain and the range of a function from this graph. As we said earlier, domain will be the x values and the range will be the y values. So if we have this graph here, the domain will be from the beginning of the x to the end of x. So the domain is where we have the blue line, the beginning of the function and the end on x. Now with the range, we can draw a line and come down straight to the y. So we can see the y beginning and the end also is the range. So the next section, the range means the beginning of y to the end of y value from the graph. It's our range. So range is all the possible y values in the graph, and the domain is all the possible x values in the graph or the function. So now they say we should use the graph of each function to determine its domain and range. So to use the graph is very straightforward. We look at this graph A. Let's start with the domain, which is x. So the beginning of x is here to the end. So actually the x will be all the line because we can see the graph end at the line. Oh, sorry. The graph end at the line. Now with the range, Look for the lowest y value, which will be where my cursor is going. And then the highest is at the top here. And the same thing we do for the rest. So let's go through each of these problems one at a time. So we start with the A. We can see that the domain is from negative infinity to positive infinity, because we can see the arrow, the function, there's an end, or it ends at the last end of it. And the beginning also the same. So negative infinity to positive infinity because of the arrow. Now, since the arrow shows, that means it's keep going. It's keep going. So with the range, since we have this down, keep going, that means we get negative infinity of the range also. But we can see that the highest that we go at the top is up to, yeah, we assume each box is 1. So 1, 2, 3, 4, 5. So we go up to 5, then we went down. So the maximum is 5. But when we are going down, the arrow indicator means we stay going. So it's going to be negative infinity both sides. So that's why we say negative infinity to 5 for the range. But the domain axis, we see arrow to the left, arrow to the right. So negative infinity to positive infinity. Now let's see the second one. The same thing, when we look at the graph here, we have an arrows, and the graph also have an arrows. And it's not really going too fast, but we're still going towards left and right. It's not vertical. This is a graph going towards left and right, but very slow. So this means the domain will be negative infinity to positive infinity because of the arrow of the graph continues. Now with the range, we can see that at the top is going, the arrow of the graph is going, so it's continue. So the upper value will be positive infinity for range. But we can get a lower value. One box represents 1. So we get 1, 2, 3. So we start from negative 3 to positive infinity for the range. So that's the green line. Now let's see the domain of this function. We can see that this function is discontinuous at, we assume each box is 1, so it's discontinuous at positive 2 when s is positive 2. But it doesn't matter for us. The main thing is that where is the beginning of the function and where is the end? This function doesn't end, and there's arrow at the function, so it's keep going to the right, and there's arrow to the left also keep going. So that means the domain is negative infinity to positive infinity. But when we look at the range, we can see this is a form of parabola, and it starts from 2. Each box is 1, 1, 2. So that's the minimum. So, but again, we can see that the arrow is going up. Here, this is constant for y. It's going towards right, doesn't go up. But this very parabola, we can see that the arrow is going up. So it will be positive infinity. So from positive 2 at the lower to positive infinity, and that will be the range. Again, since the parabola section to the left, the arrow is going up, and then the linear horizontal, the arrow is going towards the right. The domain will be negative infinity to positive infinity, and the range will be from positive 2 to positive infinity for the range. So we have another function here, and the goal is to find the range. We are assuming this is a full function. So when we look at the domain, we can see that to our left, we keep going. The arrow is still going. But it will end at asymptote, which is 1. The vertical, you can see that the vertical line here, the graph doesn't touch it. So it will not go through 1. So that's why we say from negative infinity to 1. Then from 1 to positive infinity. And this symbol means union, which is end. So from negative infinity to 1 and 1 to infinity. The graph doesn't touch. And then when we look at the range, also the same concept. So we can see that the range will go from negative infinity to 0. because this is where we end 0. Then from 0 to positive infinity. Because this graph doesn't touch 1, so it's somewhere around right before 1 through 0. So the range will be from negative infinity to 0, the range, negative infinity to 0. Because again, we start from here. You can see that this graph, it doesn't touch the 1. And also when it comes down, it doesn't cross to positive side. It ends at 0. And this is also the same from 0. It doesn't go, this part of the right side of the graph doesn't go to the negative section. So that's why we say to 0. So it's like the vertical line, the asymptote is at positive 1 for the domain. And the horizontal is at 0. So we can see the graph vertical, it doesn't cross the 0. And here also doesn't cross the 0 to positive. So that's why we say the range is from negative infinity. Negative infinity is down here to 0. And from 0 to positive infinity at the top. So now we're going to recognize the graphs of common functions, especially in algebra. The first function we're going to recognize always is linear function. Linear function means the expression highest exponent is 1. So the function is straight. And also we have what we call the parabola. Parabola means the highest exponent is 2. And sometimes it may open upward, sometimes it may open downward. Now, if it's positive, s squared, it opens upward, parabola. If it's negative s squared, it opens downward, looks down. We also have a s cube. S cube, always, this is the cubing function. This is the form of it. Then we also have the absolute. Actually, we saw this in one of our example. We have 2 absolute x plus 3. Because the variable is absolute, this is at the form of the graph, because you get the negative side of the value, which will be the same as the positive side, because absolute value of 2 and negative 2, or any negative and positive value, the answer is always positive. So you are going to get two like mirror reflection of the negative side and positive side. We also saw the square root function, which look close to log function. And also we have the cube root function. The cube root function. Always that's how the shape looks. So this will be the conclusion of our lectures. Again, in these lectures, we went through the concept of, again, how to graph a function, and also how to use the vertical line to test a function. Now, using vertical line to test a function means first you have a function, you have to plot the graph of the function first, then you draw a vertical line across it. If at any position of the vertical line on the function, the touch is only once, or the intersection is only once, then it's a function. If it's more than 1, then it's not a function. Also, we learn how to determine function values graphically. The whole concept here is how to read your graph. If I know, the x is 2, go top till you see the intersection of the point and draw to the left or right to see what value is y. We also want to try to find the domain and range of a function. So the domain will be all the possible x values in the function from beginning to the end on the x-axis, horizontal. The range of the function will be all the possible value on the y-axis from up down, the beginning to the end. So again, wish everybody the best, and thank you for your time.